Radio Wammo Breakfast, that's 16 minutes past 9.
The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
In Melbourne City, it is Janine Young with us. Hello to you, Janine.
Good morning.
Good morning. Now, a couple of big stories to get through, actually. So let's start with this first one that looks very interesting, about a volcano that shaped human evolution.
And better yet, this is not just a volcano, this is a super volcano. About 74,000 years ago, so a little bit before you and I, there was a volcano on the island of Sumatra, so that's in Indonesia, that exploded. Now, that in itself doesn't sound unusual, except for the fact that it spat out twice as much magma as the equivalent of 2 Everests. So that is a vast amount of magma. The ash covered ridiculous amounts of the planet. It had a massive effect on the climate. However, part of what's interesting about this is there's now some dissent, if you like, about just how serious the effects of that would have been. There's been a cataclysmic theory where they said that the temperature would have gone down by about 2.5 degrees for well over a decade. Because when a volcano puts out ash, it also spits out sulfur, sulfur dioxide and the like. It reacts with the atmosphere, reflects heat back into space. We know about that through pollution at the moment, shipping and the like. We know that if that gets reduced, then actually it's going to help warm the planet as well. But that's a separate story. Now, in terms of this volcano, there's some dispute about just how serious the cataclysmic or otherwise effects of this would have been. Because when you think about ash being spewed out across an area, if you have ash across the place that you're attempting to hunt or gather or grow your food and you're trying to drink water, then it's going to put a severe strain on that kind of environment because you can't grow anything with ash over the top. It starts acidifying oceans, it affects water supplies. Indeed, after the Canberra bushfires in 2003, they found that some of the supplies for Canberra, the dams, were affected by the ash falling into it. And that turned out to be quite a serious problem, but that was only for 6-9 months. This potentially could have gone on for years. However, a number of scientists and researchers are looking at just how serious this was, and a competing theory is saying that it actually really wasn't as bad as they think because it was mostly an ash supervolcano as opposed to a sulfur supervolcano. And they're saying that maybe it was only 1 degree for maybe a few years. And this is important for human evolution because around that sort of time, the current wisdom is saying that, Homo sapiens, that the modern humans hadn't yet left Africa, and they didn't do so for really a little while yet. They didn't think they got there until 60,000 years ago. So that leaves 14,000 years where they're saying, well, this couldn't possibly have worked, and so, the ash patterns, doesn't show anything. But they're finding now that there is evidence for modern human tools and the like in these areas where Mount Toba did explode. And so they're thinking that there may have been 2 migrations out of Africa. There was a failed one that they know about 125,000 years ago, but they think that there may have been some early humans, Homo sapiens, who did make it out of Africa instead of those who were only thought to come about 60,000 years ago. So some of the evidence is showing that perhaps these migration patterns might have changed and they might have been forced out of certain areas because of the way Mount Toba exploded and the way it didn't work and what actually happened. Fascinating story. Very complicated, so it's a really good one to sit down and actually spend a Sunday afternoon with because, no one else has anything else to do but to read New Scientist.
Yeah. Well, one can only imagine about early human civilization, and it's absolutely amazing that we've got to where we've got, because I'm sure that there are events like these volcanoes that could have just potentially wiped out whole populations and prevented us from actually surviving full stop.
And that kind of thing is really important for evolution because it's very possible that if it was even just a bit more cataclysmic than this lower theory is suggesting, it can produce a thing called a genetic bottleneck. It means that there's only a limited number of breeding pairs. Yes, I'm talking about us like we're animals. Fundamentally, we are.
Yeah.
You only have a certain number of individuals to be able to breed. Now, that means that you actually potentially, if they're isolated from one another, can have different populations arising from limited numbers of breeding pairs being in a particular area. And that's also possibly some of the reason that we have different groups of genetically different humans in various parts of the world. It's very possible that it started from these sorts of genetic bottlenecks. No one knows for sure. They haven't found any bodies in any of these areas because Sumatra, being a tropical area, is not particularly good for preserving bodies. Everything rots in tropical areas. So it's unfortunate that we don't actually have any skeletons to be able to compare any of this with. But the tool usage around this sort of area is suggesting that they're actually modern humans as opposed to being Homo erectus or Neanderthal. So, you know, it's fascinating. It's a really kind of exciting story about the fact that what we think, once again, may be wrong.
Yeah. Well, this next story is kind of related to what we've just been talking about, human evolution. Looking forwards, you know, how far can we go physically and mentally before it's too far? Like the 100-metre sprint, you know, how fast can we go?
Interestingly, probably not a lot faster than the way we're going at the moment. When Usain Bolt did his massive, and I have to check numbers here to make sure I don't get this wrong. I did it last week again. I apologise. He did, I think it was 9.48 seconds, or 1.11 seconds off his previous world record.
Yeah.
And they're thinking we can probably only get down to 9.48 seconds. So we've got 0.1 of a second to go because there's only so much a human body can do. It comes down, they think, to our power to weight ratio. The fact that you get beyond a certain point, the benefits of stronger muscles and stronger limbs and the like is outweighed by the energy that's required to actually shift the damn thing around.
Yeah.
It becomes too heavy. So it means that there's a natural limit as to how fast you can go given these constraints. And you know, it's like holding your breath underwater. The current record is a bit over 11 minutes, and you can actually achieve this by, you know, obviously holding your breath, but you have to hyperventilate first. You put your face into chilled water because it kicks off the diving reflex. It's something that we do as humans. You see it in babies. The Nevermind cover, the old Nirvana album, is exactly that. The baby looks quite happy. It's not the slightest bit distressed because this diving reflex has kicked in. And they found that potentially we could get up to 15 minutes holding our breaths underwater if you do all this preparation first and you practice. This is not you or I falling into a swimming pool.
Yeah.
And they think that, you know, up to 15 minutes we could do it. Now, my question around all this is, why? I like breathing. It works for me.
Yeah, but we like pushing the limits, don't we? We like exploring the limits of our potential, and that's without growing gills.
Yes, exactly. And I've seen Harry Potter. I know about gillyweed. Fine.
What about weightlifting? I mean, how heavy will be too heavy?
Weightlifting is one of those ones that, again, I need to check my notes because this one is bizarre. There are vast numbers of people who love weightlifting. And again, don't quite get it, but that's just me.
Yeah.
The limit at the moment is 457.5 kilograms for a lift to the thigh, and overhead lifting is 263.5 kilograms.
Wow.
Now, don't think again that we're going to be able to get much more than that. Pretty much at the limit at the moment because it comes down to the strength of our muscle fibres. Generally, there's a reaction in our muscles that says, no, you're not meant to lift any more than that. This is not good. But they're able to shift beyond that, to be able to fight the urge, if you like. It's a bit like breathing. Yeah. There's a natural gulp reflex that kicks in. So a lot of these weightlifters are kind of operating, again, at the edge of what they're able to do. They're able to suppress the signals that are telling them, no, that's too much, don't do any more. Because if you actually start doing too much, then you can actually start tearing muscle fibres, and often it happens around the tendon, which is the bit that attaches the muscle to the bone. Not good. You don't want to do that kind of thing because you get some pretty serious injuries out of weightlifting.
I tell you what, I'm all for eventually the medicated Olympics. You know, an Olympics where... Yeah, it's no holds barred. Is that the doctors are there, they're prescribing the right drugs, and just finding out how far people want to go. Because no doubt, I mean, there are a lot of athletes who would rather go down that route and just see how far they can go with assistance from drugs.
Yes, well, I can see an argument for that, but unfortunately, when it comes to running and when it comes to weightlifting, steroids ain't going to change what we've already got. There are natural limits that are on our bodies. That means even with steroids, we could probably only push them just a little bit more.
Okay, was it the Bionic Olympics? robot technology mesh with human flesh. Let's see how far that can go.
I can see you're a bit over the Olympics as it is, and you want more.
Yeah. Absolutely, that would be an Olympics I would definitely want to attend. Yeah.
I don't know what to say to that.
Maybe not for everyone. Janine Young, thanks so much for that. Those stories you'll find in the New Scientist magazine, which comes out next week, and we'll talk to you next week.
See you next week.